onto each other so you don't get your shop head laying over. And you need the proper size gun, which we'll talk about probably tomorrow, at the proper pressure. You need proper pressure on your bucking bar, and you need to drive it the proper amount of time. All that's going into getting a correct shop head. But if you've been riveting a day or two, you're kind of getting the feel of it, and you're like, man, this is going good, grab another handful of rivets, and all of a sudden it's all over the place. If your tails are consistently getting too long, and you've already kind of figured out how to rivet, maybe your rivet length you calculated incorrectly and it's actually too long. Or if you're all of a sudden smashing them into teeny tiny pancakes, maybe your rivet you calculated wrong, or somebody put the wrong size in a bin. That happened a couple years ago. That was very frustrating. So if that's happening, check your rivet, like, oh, is this the correct length I need? So just kind of keep that in the back of your mind. That's something that could unfortunately happen. We will not do that to you on purpose. I will tell you that. But when you have 28, 30 people using different rivet bins, bad things happen. But you are a quality class, so I'm sure that will not happen among you.
You see that every class?
I did not say it last year. Moving on. You learn things the more you teach as the years go by. So this is a slide I actually pulled from Ryan's slide, so I know you have been over it before. So could someone tell me, starting at the bottom, what does all this mean? MS-20426.
Military standard.
Nice. Military standard. Excellent. What does?
To of course the type of rivet.
Very close. Very close.
426
Ooh, so does that tell type of head? Ah, so very good. So actually, the MS-20 is a military standard 20, and then 426 is the head type. Very good. Or head style. What does does that mean Dunkin' Donuts?
Is it like the markings on the head?
Perfect. Oh, well, yes.
The D is like
Exactly.
the
Yep. It is indicated by the markings. And what does that tell you? Exactly. Alloy of the rivet. Then, what does those little 5 mean? 5 donuts?
diameter.
Perfect. Diameter in 30 seconds. And what does 6 mean? Length in 16. Awesome. So now, what does AN mean? Army, Navy, or Air Force, Navy. I've seen both. What specifically head does 470 mean? And now you can grab AC 4313 and look where you would find that information. Very good, very good. I'll give you a, next year I'll make it a harder one.
Universal head.
Perfect. And where did you find that?
Page 417,
So,
table 48.
go to page 4-17. It has head styles. And also, what type of alloy is AD?
2022.
AD. 2117T. So if you go to the tippy top of that chart, that'll show you that. And then we got diameter and length. Go ahead, take a break. Make sure you have the general airframe volume 1, AC 43 tables come back at 40. Oh,
That long with the plan on. Careful.
yeah.
That's the whole reason why I'm in Michigan.
Wait, what's that?
Oh.
I think it's 7.
So I get the pizza dip. The pizza thing.
American first does the Christmas thing, right? Christmas shoebox.
Yeah, I guess.
Oh, yeah, we didn't have to.
I really should probably, 'cause, you know, the whole joke aside, like, that is why I'm here.
I didn't like
Aviation.
answering the phone because they were all jammed with
Okay.
stuff, so
I would probably
Yummy.
you answer the phone and they, you know, they don't think about that.
I don't know what it is like yet. Because. And then again.
Probably like 10 times in one conversation trying to take an order, you're like, what do you want? What? What are you saying?
And so I didn't.
Honestly, it's
I'm like, no, my
Yeah.
earpiece are someone else.
Yeah.
even before coming here.
Get the
But I want to hear more about their aviation.
Oh, sure, you're saying.
They're sharks.
Still, but then you're also
But they're just ones that are kind of like stand by wherever they're like humanitarian needs might pop up.
they don't
Call them like 24 hours later on a plane ride to the Citadel place.
Yeah. I feel like the suspense would be a thrill.
Maybe, go
So minimum wage for situations like that, they can actually go down.
They're gonna find $1 an hour.
So if you have like
Yeah.
Hit the dragon.
Also kind of like
All four. Which is kind of part of the romance of it.
You're doing 12 hours.
Yeah.
Pick up your coat.
What is sleep?
you're eating whatever you eat.
It's like you didn't even move. Just like put the toes here
Yeah.
into the oven.
It's called a purge. You need a good purge.
So it's like kind of supposed to be safe.
Yeah. A thrill, right?
Yeah, definitely. But I like this phone driver. I'll hear about their aviation.
When you first said it, I'm like, that could very easily.
Oh. Try to look innocent, don't you? I was literally walking with my stick. Oh, it's good Christmas coming soon. You all need a break. Okay, so back to AC 4313, page 4-17. So get familiar with that. Just know how the chart works. On the left side are styles of heads. Across the top is the alloy, and we're going to talk about the doctrines and doctrines and all those things. But I wanted to kind of make sure you understand head styles, because just looking at a little teeth down the road, it's hard to see what actual style it would be. So I'm going to exaggerate them a bit from how the book shows it. So the flush heads are pretty obvious because they're flat on top. But a round head, what do you call them on Reddit? That's great. So a round head rivet, I'm going to draw the shank and is, well, I was going to say a mushroom, but there's all kinds of mushrooms. But it really is more of a half circle. It's very round. Then we have what is called the flathead is just completely flat. It's no countersink to it like this. Countersinks down into the metal, so your metal would actually be like that. Where the flathead is just a T sitting on top of the metal. So that's kind of difference between flat head and flush head. So don't be calling a flush head a flat head, because a flat head is not a flush head. So then next is a brazier head, and it's kind of hard to tell the difference in AC 4313, at least I think, between brazier and round head. were to hold these two types of rivets up side by side, it's hard to tell. But it is more of a flattened out circle. So where this is more of a half circle, this is more squished, but you still got rounded on top.
Which do we use more often?
I will tell you. So then, the universal head is an example down at the bottom. Universal head looks sort of like a brazier head, but it has kind of a more flattened portion on top. So we are round up on the sides, and then it really flattens out on top, which makes it a lot easier for drilling out. Now, looking at those, first of all, which do you think are the most common ones in aviation? Which do you think are the kind of ones you've been drilling out? Yeah. Flush and universal. So this is the one that's most commonly used in aviation. And again, even when you have the rivet in your hand, like I thought about showing them under the camera thingy, but it's really hard to actually tell. So when I exaggerate, hopefully kind of understand what's going on with our heads. All right, any questions on that? Yeah.
Do you use a different bit in your rivet gun for?
Set in your rivet gun. I thought you meant bit in your drill. Set in your rivet gun, you'll use, there's one kind of cupped for these guys, and then the flush set for flush
You can
rivets.
use a couple for all three of those?
Yep.
Okay.
Yep. Good question. There we go. So identification of rivets, any question on the review of what the identification code is? So now diving into types of rivets. The AD, which is 2117 alloy, and this is a number that the FAA will want you to remember. That 2117 AD rivets are the most common in aviation. So if you want to make up a little Christmas song about 2117 or whatever, you can do that. Because they are high strength and have good shock resistance. It's an alloy of copper and magnesium. And the most common style of 2117 is a universal head. So you can kind of tell it comes curved up, flattens out, and curves down. And a universal head with a single dimple. And you can see that on page 4-17 of AC 4313. Now for countersunk rivets, so they are also commonly used, and they are used where you want good aerodynamics, like over the front of the wing where you want smooth airflow, you want the least drag. So used in critical areas where they need smooth airflow. I will talk more about countersunk rivets, how to install them, all that stuff later, but just all you need to know for now that they're used where smooth airflow is desired. And then ice box rivets. So these are the D 2017 and the DB 2024. These are the special ones. They're called icebox because they have to be heat treated and then immediately used or stored in a freezer. They're in their original state are very hard and susceptible to cracking, which is why they're heat treated. Soften them so that they can not split when you drive them. So they're soft when you drive them, which means that they're going to need a period of age hardening before they're considered then when you remove them from that freezer condition, they'll tell you on the box, you must drive these rivets within 1 hour or whatever it is. If you leave them out of the freezer for too long, then they have to be heated, otherwise they'll crack and split when you try to drive them. But the advantage is that in their frozen state, they're actually soft. So you can drive them with low pressure, which means pretty carbon fiber composite aircraft that you want to be really careful not to crack stuff. They will use these icebox rivets. They can be driven with softer pressures, less damage to surrounding structure. Let it age harden for whatever, for 8 hours or whatever they will tell you. And then you have a really nice finished riveted structure. And that's a RV of a relative of a friend of mine that I got to see in, I believe they used these icebox rivets, and then she built it herself and with it. Any questions on, yes?
Does the image on the right exactly where you put a years on the?
It is.
Does
Yeah.
that affect the set that you're using at all, send those years on it?
No, it shouldn't, because that, like you said, is extremely exaggerated. It will be just a little bit, yeah. However, so now it is a raised dot or raised dashes. Oh, here's a way to remember it. So if it's a raised dot, that means it's one D. But if it's two raised dashes mean a double D. So it actually did something that makes sense. But yes.
Yes. So like with the age hardened rivet, how much harder is it to drill out? Is it harder?
That's a very good question. I don't know. I don't know how much of a difference. I don't know if it's noticeable or not to drill it out. It's an excellent question. I don't know. It's a Ryan question. See if he's ever drilled out PD rivets. I'll get to you in a second. If you are drilling these out, I had talked about not filing universal head rivets with a one dimple. Do you think you may need to file these off before you try to drill it out? Yeah. So this is one of those you might want to just very carefully file that down so you can let you drill it out. Yeah.
You should advise people to be length of the river.
So we'll talk about that. Yes, sometimes you get a rivet that's too long, you can cut it down. It makes it more difficult to get a good shop head when you buck it. So if you're going to do a big project, you're going to order the correct size. But since you asked the question, I'll give you a secret. You will be cutting rivets at some point in the class just to get that experience. Yeah.
How do you treat it, what method you use?
It would tell you when you order them, manufacturer's instructions. There you go.
Most shops don't have the capability to choose, so they get it first.
Yes, correct. So, but he said, you may not have the capability at your shop depending on where you're working. So it's very important, you order them, and they come frozen. That's how most people receive them. So you really have to pay attention to how long do you have to drive these, how long can they be sitting out of the freezer. Or if you don't have the proper equipment, you might have to send them back to the company to get reheat treated, pay for that process and everything, depending. So pay attention to the time frame. And don't leave them sit out and go enjoy a nice long lunch and come back. Any other questions on those? So aluminum rivets, and you'll be doing these in your sheet metal project. And since you're such a good class, I'll give you this heads up. So it's super easy as you're going down through that project that has all those different plates. Most of of them are gonna be AD. See that? Grab a AD, grab a AD, grab a AD. Aluminum rivets are whatever it is, and 470. A 4 dash, whatever it is. Super easy to miss that the D is not there. So when you're reading your instructions or reading a manual, pay close attention. Is it A, or is it AD, or is it something else? So that's how they are signified. Just A means it is a plain head. No dimples, no raised dots, no dashes, no nothing on the head. Aluminum rivets are, they say, 99.45%. You don't have to memorize that number. Pure aluminum, so almost pure aluminum. And these are, because they are soft, non-structural use only. So things like bearings or baffles or plastics that you're fastening together, things like that, they'll be used for. And yeah, low strength, non-structural. Most important thing to remember about aluminum. Then we have 3 special kinds of rivets. Taking a look at this where they use copper rivets on a steel bar, what do you think these 3 special rivets, what the reason is for them? Prevent galvanic corrosion. Yes. So Monel rivets are used for riveting nickel steel. And the FAA loves to ask you all kinds of questions on these 3 guys. So whatever method you have to remember which rivet goes with which metal, memorize it, is what I can tell you. What helped me is Monel, the N goes with nickel steel. So Monel to nickel, if that helps. And then 50-56 rivets are used for magnesium, because magnesium is a chief alloying agent in 50-56. So I didn't really come up with a good way to memorize that one, 50-56 magnesium. Whatever helps you with that. And the last one is mild steel rivets are used for corrosion resistant steel. So at least steel goes with steel. And it is used for firewalls and exhaust stack brackets, things that are made out of that steel. So if you remember steel with steel, Monel with nickel, and then 50-56 is a leftover with magnesium. Maybe that'll help. Rivet strength and stresses. So if I have a riveted joint, this was a question that a couple people missed on the quiz. Do I want it to fail in bearing first or in shear? Excellent. You all answered correctly now. And what type of loads cause the most rivet failures? Oh. Very good. So you want the joint to fail by shearing, because if the rivets don't shear off, then the metal will tear, and it'll be a much bigger repair needed. So when we start talking about how many rivets and what type of rivets, the whole design reasoning that goes into that is knowing the shear strength of the rivet, and that has to be slightly less than the bearing strength of the metal. So when we start looking at charts and manuals that tell us how many rivets per inch or something, thankfully we don't have to do the engineering formulas to figure out the bearing strength of the metal or the shear strength of the rivet. They tell you that, but that is why you have to have a certain number of rivets for a certain metal. most rivet failures because that is what they are designed for. They're doing what they're designed to do. One little tidbit, if a rivet is holding two pieces together, that is called a single shear load because this one's pulling that way, that one's pulling that way, so there's one area of the rivet that would be cut apart. However, if it's three pieces, now that rivet could be sheared there and sheared up here, so that's called double shear. I don't think you're specifically tested on that, but you may run into that terminology. So single shear, just two sheets where it could shear the rivet in one place. Double shear, the rivet could get sheared in two places. And anything else I need to hit on that? Don't think so. Any questions on that? Okay. So here's a tricky thing. You want to replace rivets with those of the same size and same strength as original whenever possible. So that is key. And why you need to be very careful with drilling, laying out your rivets, so that you can, if you need to replace them, you do not enlarge your drill hole at all. So you can use the exact same rivet of the same strength, so you get the correct shear strength and bearing strength as the original. However, if you go to AC 4313, page 4-16, and paragraph Dorado is where that statement comes from. Replace rivets with those of the same size and strength whenever possible. However, there is an allowance. When you have an allowance, that doesn't mean you can just go do that whenever you wish. But if you're in a tight spot, if there is significant damage and your drill hole got enlarged, you may use the next size larger rivet within the minimums. So, looking at that paragraph, it gives you a whole list of scenarios. So the important thing is you don't want to, bless you, if you have your rivets too strong, you size up and you have a strong rivet, what could happen to your surrounding material? Your material can now fail before your rivet, and now you have a really bad repair you need to do. Or if you decide for some reason to put more rivets in, same scenario. So rivets may not be replaced by a type having a lower strength property, so you don't want to replace it with a soft rivet or something, unless the lower strength is adequately compensated by an increase in size or a greater number of rivets. So, if you're going to use a softer rivet, how would you know how much bigger to make it or how many more to put in? And your silence is the exact correct answer because there's not really data out there. So don't do it, basically. They give you a couple examples. It is acceptable to replace 2017 rivets of 3/16" diameter or less and 2024 of 5/32 or less with 2117 for general repairs, provided the replacement rivets are 1/32 inch greater diameter than the rivets they replace. Basically, if you have to size up, there's a lot of math and work and figuring stuff out that goes into that. So, be very careful drilling out in the world of that sort. And here are some failures. So, this is tensile failure in the material. And here, the material is sheared out, or maybe that's showing the rubber shearing out. A little hard to tell. And then here we split at the corner. This one is what we want. installing, just check your rivet length to make sure it's correct. What would you measure it with? What's it? Yes, caliper. Did you have a question?
Yeah, so typically you want to replace something that is just as strong, if not stronger, but with the case of rivets, if you want the rivet to break before the skin, can you go too far with the strength?
Very much. You can like if you size up, now you may be too strong.
Is it just sizing up, or could you use like a different rivet and that was too, like, is a harder rivet or something or stronger material than the rest of your rivet?
That could happen too. Like if you choose a different rivet, it's like, oh no, I'm out of these, I'm gonna use these other ones. And if it's a stronger alloy, then you could be ruining your project. So, yeah. So measure it with a caliper, and remember, on your universal head, your length starts at the bottom of the head to the end of the shank. But on a countersunk rivet, because this is going the whole way down into the metal, so your metal is going to be right there with the top of the rivet. So you're going to measure the top of the countersunk rivet to the bottom of the shank. And what is length measured in 1/16 of an inch. Rivet length in 1/16. So how do you know how long your rivet should be?
Depending on the material it's holding together.
Excellent. So you need the thickness of the material. And did you say the other part?
Well, that's what depends, the length or.
The length of the thickness.
And how many layers, 1.5 times the
Ooh,
Yeah,
so close.
diameter of the rivet.
There we go. Working together, we got it. So, you start with what is called the grip, which is what the rivet is gripping together, which is the thickness, the entire thickness, so all the sheets together. And then, so that's kind of obvious, because you need your rivet at least that long. But then you want to form a perfect shop head. So so here's our rivet before we drive it. If you have 1.5 times the diameter extending out, when you go to bucket, it'll squash down into the correct dimensions. So the formula, and this one, go ahead and memorize it because you're going to be using it a ton. And you're going to, since you're using it a lot, it'll eventually get in your head. So it's the grip, or thickness of the material, plus 1.5 times the diameter of the rivet. Grip is a fancy word for total combined thickness of materials to be joined. And our dimensions that we're looking for is the diameter of the squashed head or bucked shop head should be 1.5 times this diameter, and the height should be about half of the diameter. So that's the ideal of what we're looking for and why we need 1.5 times diameter sticking out before we buck it. Any questions on length? Yes.
Just backtrack a little bit, on the chart on page 417.
Yeah.
It says the different rivets and different alloys, but it doesn't talk about different diameters on that, right?
Correct. It doesn't,
So-
because
If then I look down, it gives you shear strength, but that doesn't change when it comes to diameter, so why worry about going out a bigger size?
that's a very good question. What is that based on? It doesn't say. I if you squash this, so your maximum is like, I don't know, 2 diameters. So you're above 1.5 minimum. But now, if you're squashing it out to 2 diameters, you're probably below the 0.5 here. So it works out because one dimension is this way, one dimension is that way. And you have to be above both those minimums. It works out. You can't go too far above that. Does that make sense, or was that? Okay. But that's a good question. Any other questions?
On the, figure 4-6,
Yes.
the dimension, maybe we went over, maybe that's what you're just talking about, I don't know. The dimension for the squashed rivets with the top head.
Yes.
0.65 times diameter, then parentheses 1/2 times the minimum. Is that the max?
I did see that. 0.65 D.
Yeah, on the other one it says 1 diameter minimum. That's what it stands out.
Where is that?
How do you want it?
So it's 1.5.
Diameters,
You're right.
minimum,
One
1 diameter.
minimum. Yes. Yeah. The 0.65. That'd be interesting to work that out, see if that would be it could be a maximum, because if you squash it down, yeah, you could lose the other way. I have to kind of work through it.
But
Correct. Yes. Yeah. And that's how most of AC 4313 is laid out. It'll give you minimums in areas, but not necessarily a maximum. So you want to get as close to the minimum as possible, obviously not going below it. But you don't want to say, oh, that's my minimum, so I'm going to go way out the other way. You want to get as close as reasonable. Any other questions? Oh, let's see, Trevor. Can you wake up your neighbor? I know, it's rough. Anybody else sleeping? Okay. So, figured out how to figure out length. Now, we're gonna figure out how to know what the diameter is. So, again, this is a general rule. Always, if your maintenance manual tells you something specific, always go with that. But generally speaking, diameter is going to be 3 times the thickness of the thickest sheet. So here we have a thicker sheet and a thinner one. The diameter, you take the thickness of the thickest sheet, multiply that by 3, and that will be the diameter of the rivet. And like much of life, that's not going to be a nice, clean number. Just round up. So if it's something 0.5, go to the next size up rivet. And, oh, let me see where we're looking.
30 seconds.
Diameter is measured in 30 seconds of an inch. So a little more theory that goes into laying out rivets and how spacing is engineering that came up. If it's too close to the edge, it could just whoop, tear right out of that edge. Or if it is too far in, then, oh, I think I have a piece over here. Oh yeah. So this row of rivets is actually removed. So your metal could start kind of peeling up on the edge, and then dirt and stuff can get under there, and then corrosion starts working, and then these rivets die, and then your airplane falls apart, and you die. So you need to have your rivets at the correct spacing. And then you need enough rivets to have the maximum strength of the joint. However, when you're placing rivets, you are drilling holes. Now the rivets are filling those holes, but you don't want so many holes that you actually weaken the material. So it's all about balance. Enough rivets for strength, not so many holes that you weaken the material. this is just one fairly specific example. Whenever you're using a chart, make sure you know what it's being used for. So when I copied this, I didn't grab the top, which is why I want you to turn to page 4-37. So table 4-9, this is rivets for splices, and it gives you the metals that would be for, a whole list of them, for plate, bar, rod, tube, and extrusion. So this is more so talking about like stringers and spars. And then there's notes down below it. So like a single lap sheet will be 75% of the rivets. But what it is showing is the thickness that you have and the rivet size you have, approximately how many rivets should be in 1 inch. Now this looks like a lot, and it's a lot. So this is jumping ahead a couple days. But how do you think you would get 6 rivets in 1 inch? Exactly. Stagger them. So you have 2, maybe 3 rows of rivets. You're not squashing them all together. However, there is a note under engineering notes, letter C, that says combinations of sheet thickness and rivet size above the underlying numbers, so these are the underlying numbers, so above here, will fail by bearing on the sheet. Those below are critical in shearing. So would we want to err below or above the line? So, how many say, well, if this fails in bearing, and this fails in shear, do I want to go, how many say you would want to go above the line? How many say you want to go below? Yes, because you want your joint to fail in shear. And if you look at it, it actually makes sense. Because here we have 20 thousandths material, which is very thin. So a 3/32 rivet is what we would want to use, and this one's below the line. If we go to a big old 1/8 inch rivet, now our rivet's so big in a very thin material that the rivet will pull out of the material before the rivet shears. So that's kind of how that's set up. Does that make sense? And again, be careful with these charts because they're fairly specific scenarios. Always go to the manual. Also a note with size of rivets. If you use too large of a rivet on too thin a material, besides the rivet tearing out, what do you think could happen? Are you going brrrr with your rivet gun? Exactly. It's easy to apply too much pressure, and now your whole material goes brrrr, and you have a big bulge and ruins your work. What if you have too small of a diameter rivet in your material? Then your rivet's going to shear before it's supposed to. So, not developing full shear strength. So, always use, as able, the same rivet spacing and edge distance as the original. So always go to your manufacturer's manual, and in this manufacturer's manual it says use existing rivet pattern and rivet size, which is really nice. If you have a damaged piece that you need to replace, save that, because if it's not crazy damaged, you can still use it as a template for your rivet hole placement, unless it's a little ball of aluminum dust, but hopefully you can use it at least for a template. So always use your manufacturer's repair manual first, and then AC 4313 if you don't have any other data. So rivet layout and rivet spacing also gives you the place you can come and say, I need to use original material, and gives you some reasoning behind load strength and stuff. So just tuck that away in your brain that, here's another reference I can use when I'm talking about how strong does a riveted joint need to be. I think you all need a break. So, take a break and come back at 35. Whoa.
4 minutes.
Yeah, I looked at and I looked at a number of auction sites. The problem with auction sites is you
Yeah,
can't look
auction.
at them before.
Start, it,
25 hours rather. Problem with auctions is
If I was in the woods,
okay,
you'd
I
heard
got
that.
one, and I have to figure out how to.
If I was in the woods, you'd heard it.
No, I haven't.
Yeah. I've riled up
we
these
bought
back in my day.
People call them in and shoot them auction.
Yeah.
That'd be so fun.
I have a friend who got so good at it that he like in his neighborhood all the friends hated him.
Oh, no.
They had commission drops. Right, you got time?
Some people pay extra for them. It's not like some of the auctions I found around here, like, most of them are red. There's been one or two. Looks like they really didn't do it now. They don't have any specifications. I think they do.
Corbin does. Corbin does all the joints in the world. Yeah.
So, just so I'm understanding this, we had a thickness, let's just say ridiculous, a half an inch.
Yeah.
We would times that by 2 to get the rivet diameter.
Yep.
And then we would times that by 1.5 plus the grip, diameter length.
No. So grip is thickness plus 1.5 times.
So if it was 1.5 times by 3, we got sorry, half inch thickness, we have 1.5 diameter.
Yes.
And then you do 1.5 times another 1.5.
Right. Just plus. So it's the grip plus.
Then you have a grip plus
Yeah.
1.5 times the diameter.
Correct.
So 1.5 times 1.5.
Oh, and that. Yes, in that situation. No, 1.5 times. How thick was it?
Half inch.
So it'd just be 1.5 times.
How about, let's talk about something else.
No, wait, you were right. The 1.5 is so much.
Or you do 1.
So yeah, thickness equaled 0.5. Then yeah, diameter would be 3 times thickness. So now our diameter is 1.5. And then length is thick. Total thickness plus 1.5 times diameter, so it would be total thickness. Oh no, wait, our thickness is
They never have anything but these.
0.5 plus 1.5 times diameter. I think you were saying it right. Yeah.
And then that's how you get your diameter payment. And from there, then you're trying to figure out how to stagger it.
Yeah. And we'll go through scenarios.
Slap on the back. Feel like you're down.
Yeah.
I've also had a really bad one. I got a steer
I think the first decision I think,
I might be a nurse, but I don't like surgery. I will never be an OR nurse.
But I also like,
Surgery freaks
so
me
I
out.
immediately went to.
there's a certain, I don't know, if it's a callousness or a morbidness of getting into it.
Yeah. I mean, I certainly have other things. I don't wanna deal with it.
Not at all.
So, Brian figured out how to make our, sound box work. Actually, it's really good for the starter rate, so it clicks.
That's what I was doing when I first started my stupid. So wait,
I know. I'm gonna get
you have.
Okay, let's get started. Thank you for mostly all being on time. You're on time. You actually are on time.
It's not 35 yet.
Okay, so we figured out how to figure out your rivet diameter, your rivet length, and that stuff. And then you can go to knowing how to place your rivets and space them out from each other. Because they do like a little bit of elbow room, apparently. So there are, again, minimums that you want to get as close to as reasonably possible. So there are going to be differences for a protruding head rivet, whether it's round or universal or brazier, as opposed to a countersunk rivet. Because with a countersunk rivet, here's the top of the rivet head, flush with the top surface of the metal. You're either countersinking the material and removing metal, or you're dimpling the metal down, so there's a circle, and the edges of the circle are dimpled down, so you are compromising the metal a little bit and actually slightly weakening it. So, because of that, our minimums are slightly different for protruding head versus countersunk head. So protruding head, the minimum edge spacing. So when you have a piece of metal, that means your distance from this edge in, distance from that edge in, and also distance from your bottom edge to your rivet. So you need to consider every edge of your metal for edge spacing. So for protruding head, edge spacing, minimum is 2 times the diameter. And we do have a maximum for edge spacing because what happens if it is too far from the edge? Yes, the edge will pull up, so you can get dust, dirt, and debris leading to corrosion, or if it pulls up, something catches under that edge and you can have it tear out by bearing. And single or minimum single row rivet spacing is 3 times the diameter. So this is from AC 4313. We're looking at a side view of our riveted pieces. So if you take this and look straight on the side, and then this is looking down from the top. So our rivet rows are going wee like that. So distance from one rivet the next rivet in a row, they cannot be closer than 3 times the diameter. That is a minimum. As far as maximum for a single row of rivet, it can go 4 to 6 rivet diameters. Sometimes you might see in a structural repair manual that it could be as much as 10 rivet diameters. That's rare and will be specified in the manual. So if it's not specified, you want to get as close to this as possible, but we're going to talk about some exceptions. And also this is coming out of AC 4313, page 4-19. Paragraph Charlie talks about rivet edge distance. And it talks about single row, double row, and triple row. So if you go over then to page 4-20, it shows you that for a double row, you would actually need 4 times the diameter between rivets, one row to the next row, and also one rivet to the next rivet. So a double row, and this came about doing all kinds of strength tests in engineering labs. So double row requires 4D spacing, and then 3 or more rows, it goes back to minimum of 3D. So you can kind of memorize 3D for everything except double row. And also your textbook, page 4-34, I believe it is. 4-35. 4-34 starts talking about it, and then 4-35 at the top, there's a nice chart that breaks that down. So for Parker, yes.
Those 2 rivets in the middle there, so they aren't considered as a double row?
So they're just, I think for, are you talking about these or
The ones in the middle.
like these guys?
Yeah.
So what's happening for the whole diagram is there would be rivets here, I think just for printing reasons, they left them out. But this would be a row of 4. So we got this row, that row, that row. So it's 4 rows of rivets. So that's why they go back to 3D spacing since it's 3 or more. Did that answer your question?
Yeah.
What
Yeah.
about if you stagger them?
We're going to talk about that later this week. Yeah. So then, countersunk head rivet, because we are compromising that material, all we do is take the edge and add 1/2 of a diameter. So now, minimum edge spacing is 2.5D, maximum 4.5. Of course. Yeah. That is it on, if it's not on page 4-19, that may be a more elusive thing that's, it is in your textbook somewhere, page 4-34 in the textbook. Yeah. Correct. But here, I believe, what they hopefully did, if I remember from what Dwayne told me, like they would go through manuals and say, okay, what our manual saying, do not go over, and they say don't go over 4. Again, you always go to the manual, and that will give you more minimum maximum. next rivet in a row will all be 3D for protruding, but 4D for single row for countersunk.
Oh, so that's facing sideways, not
Both ways.
both.
When we go to staggered row, it gets all different. But if you have them stacked like this, then it will be both ways. Yep. Any other questions on it? So that's where you start out. However, when you're drilling, you lay out, you mark your holes, you drill the holes. I'm gonna tell you right now, you can't be perfect. So you need to allow room for error. And so hopefully you look at it ahead of time so you don't make a huge mistake. Calculate your fence holes. However, keep this in mind. A person, and this is Mr. Albert Einstein, a person who never made a mistake never tried anything new. So hopefully that can be an encouragement to you as you go through rivet layout and drilling and riveting. That because when you make mistakes, you're gonna make them. Everybody does. It's because you're trying something new, which is a really good thing. So keep at it. Because of this, here's what your textbook tells you versus what is actually practical in the field people doing. So your textbook says add 1/16 inch to minimum edge distance to allow for error. Now, this will allow if you've done 3D spacing and you get a little wobbly on your drill placement, 1/16 inch will allow your rivets to still have 3D spacing between each other. But what if you make a bad mistake and you do have to go to the next size up rivet diameter? Then you're in a pickle if you've laid out all your rivets to the very minimum. So what is allowed and acceptable and recommended is to determine distances with the next size up rivet diameter to allow rivets to be oversized without violating minimum. And we're gonna go, I'm gonna have you do this for your lab. So if you have a size 3 rivet that you'll be using, you'll actually do the math with a size 4 rivet. So your spacing will be for size 4. Then you do the math, figure the layout, which we're going to talk about. Then you go back and actually install the correct size 3 rivets. But make a mistake and your drill goes crazy, you can size up and your number 4 rivet will then still be above minimum. Layout.
This only relates from edge distance or also center to center?
Both edge distance and center to center. size up rivet for your edge distance. So you take your piece and mark your edge distance on each side, remembering that is distance from the side, also the distance from the bottom of the edge you're riveting. You mark that on each side. Then, what if we can mark that way? Yes, Sharpie. And the ultrafine tip is really nice because you get this teeny tiny dot instead of a big splotch. So the more fine it is, the more accurate you can be. So then you have those two little dots. Also, here's a very helpful tip, especially if you're like me and you made some wrong marks when you do it the very first time. Just take a piece of tape and lay it across and mark on the tape. And then if you get it right, you can drill right through that tape into the metal. If you get it wrong, all you have to do is tear off the tape, put a new tape on, you don't have to try to wipe off the Sharpie mark. So, there's a helpful tip. So you got your two end rivets marked. Then you measure that distance from between the end rivets. So you mark there, you mark there, you measure that distance. Then, since you already know your rivet diameter, you'll know the required minimum distance between rivets. So you take distance between end rivets, divide that whole distance by your required spacing, so whatever that is, if it's 0.375 or whatever you figured out. Then that'll come to a number, something like 3.428, some random number. It rarely will be a whole number, so you round up, or even if it's 3.15, add approximately 1, so just round up to the next whole number, and that will give you the total number of rivets needed. Because if you just divide the distance by the spacing, that actually gives you the number of spaces, and you'll have one more rivet than there are spaces. That'll make sense when you lay it out and look at it. Number 5 is, it depends how accurate you are if you need to do number 5. 5's kind of optional. Try it without 5, and then try it doing that, and you'll kind of see what works best for you. But if you get a weird number, you can take the distance between end rivets and go back to step 3 and divide the distance between end rivets by the original whole number you got, and that will give you exact spacing for even rivet placement. So sometimes this number will match what your actual spacing is supposed to be. So if your spacing between rivets is 0.375, and you come to here and you divide it by this whole number, and it could be 0.382 or something. And what that does is then every rivet will be an exact distance from the other one. Otherwise, your last rivet will kind of have to smudge it a bit, and it'll be a slightly different gap, which is okay, as long as you're above minimums. But again, when you're laying it out and doing this, it's going to make a whole lot more sense. Moral of the story, you can't be 100% accurate. So start with marking the rivet placement at outside edges. You go one end to the next other end, and work towards the middle. So you'll do one rivet at the end, rivet at the other end, this side, that side, this side, that side, and then the last rivet, center it between the two previous rivets. If you go from one end to the other end, because you tend to not be exactly accurate, then you probably have either a really huge gap to get the correct number of rivets, or else too small of a gap, and it'll look sheet of metal that is 4.25 inches long. And we're going to use, actually, let me do it like this. Up on mushrooms. Everybody got a friend as his email?
Yeah.
Oh, this was a really good diagram. Alright. So, the rivet is AN 470 AD 3-4. We've already figured out length and diameter. So, I was going to have you calculate diameter. No, that's okay. So, what should my edge distance be if this is my rivet?
Which is 4 30 seconds. 4 which is a quarter.
Excellent. Did everybody follow that? So, we have a 3 30-second rivet we actually want to install. But, because we're prone to error, we're going to size up and do the math and spacing for a 4 30-second rivet. And then 4 30-second times 2 going to be 0.25. 0.25. Any questions on that? So, we come and we go, okay. There, I figured out we want 0.25 from this edge and 0.25 from that edge. So where those lines cross is going to be our first rivet. Whew, finally got our first rivet laid out. And then we go to the opposite side and mark that rivet. Now, knowing that we are in from this side 0.25 and in from that side 0.25, what should be our space between these two rivets? 3.75. Show now. Oops. 3.75 there to there. So, a tip for you, when you actually do this on a piece of metal, mark that rivet, do the math of what this number should be, and then go back and measure from where you mark that rivet to make sure it's as close to the math number as possible, because you might be a little sloppy and actually have made that mark in a little bit or out a little bit, and now you're measuring 3.61 or something. So just try to get as accurate as you're supposed to be. And what would our minimum spacing be for our scenario?
Single row?
For a single row.
So that'd be 3 diameter.
Excellent. 3 times the diameter. And in decimal form, 0.375. Excellent. So that's going to be from one rivet to the next. And then we take our usable space. So this is where we take 3.75 and divided by our required spacing between rivets, which is 0.375. So in a scenario like this where your numbers are very similar, be super careful with your decimal point, because I've seen people our number of spaces, we bump it up to the next number. So this time we add a full 1 on it to get 11 rivets total. So, all that. Now we know that we have to fit 11 rivets total, that's counting these end rivets, with spacing of 0.375 between each rivet. So we measure from this guy, 0.375, and mark a rivet. Then we go to the opposite side to help account for error. Lay that rivet and keep doing that. Do, 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 do. And by this time, hopefully not, but if you're like me, when I started, you'll probably be a wee bit off. So instead of going 0.375 from this rivet or from that rivet, just measure that space in between and lay him right in the center to make it look nicer, distribute strength more evenly. Questions? Yes.
So where did you get your 3D?
That's minimum spacing between rivets in a single row.
Okay. And so the chart on AC 43 page 4 says that, which is the thickness of your material, is how many rivets?
So the chart on 4-37 is for more specific stuff like stringers, some of that stuff that you see on that page, left page. So, and those metals at the top of the chart. So if you go over to page, where was that? Page 4-19. It talks about general rivet edge distance and single row, not less than 2 times diameter, or for edge distance, and 3 times the diameter for spacing. So that's where that comes from.
Thank you.
Good clarification. Appreciate it. Any other questions? And tomorrow, I'll go over this again, probably using like actual sheets under the camera. So this won't be your only exposure to it. But if you start kind of seeing how it works, and by the end of your sheet metal project, you'll be such experts. So as you get ready to lay out rivets, remember, do not mark directly on aluminum. Do not score it. Don't do bad things to your metal. So, recommend lay down the masking tape, mark it with a fine tip Sharpie, and for your measurements, machine the scale, caliper, whatever you can get the most accurate with. Be as accurate as possible and try to make your errors manageable. So, as in, when you lay out the rivets, go one side to the other side, bring them together. And start to understand your limitations. So, you'll learn, oh, my first 2 rivets I tend to kind of get off, so I need to make sure I go back and measure that distance to make sure it matches mathematically what it was supposed to be. Or, oh, I lay my end rivets beautifully, but I really start to lose it when I lay them out in between. So you'll learn what areas to work on, what you struggle with. Let's see. I think instead of torturing you with prepware questions, I will let you have some lab time. And I'm going to hand out a lab. Don't get too excited because we are only going to maybe be starting on step 1. So this is your riveting project lab that's going to last 1, 2, about 3 weeks. So,
Yeah,
there's
and done that.
a lot of steps to it, but don't freak out. I mean, you can if you want to, but it's not my fault. That was like one row. I don't know if you want, like, if you get stuff done, there's actual things. Uh-oh. I do. I was like, oh no. Okay. So, if I can have your attention back, it would be much appreciated. So, on the front is just the grading criteria. Remembering that cleanup is a part of that, safety, big part of that. Make sure you're wearing your safety glasses, operating in a safe way. So, step 1 on page 2 says material rep, practice pieces. So, how this whole, I've already good. So we have this whole thing that in the end you're gonna make, but first, we start with these 2 pieces, not that row up here, just this row, that you're gonna use practice pieces and do it first, and then later you'll cut out the actual new aluminum stock and do this for this project. But initially, all we want you to do is take some used aluminum. So that's why I want to make de-skinning the wing priority, so we have used stock to actually do this with. So work on getting the wing the rest of the way apart, and I'll also need the ribs, but that's not as, that'll be after Christmas that I'll need the ribs. So right now priority is getting the skin off the wings so you can use that to make these practice pieces. So if you, and you can use some of the other used stock that's back in the corner of the sheet metal shop. Look for, I would like, if you have 25 thousandths, 20 or 25 is ideal, but 32 thousandths will work. So if the 25 gets used up, 32 thousandths is okay for the practice pieces. So you'll need to make 3 pieces. So kind of that size there. And your finished piece is going to need to be 3 inches by 6 inches. So if you have a big piece of used stock, what I want you to do is cut it, and you can write this down if you have a pen. Cut your initial piece with a foot shear 4 by 7. So, and you can cut those pieces as groups or whatever. We can cut a bunch of 4 by 7 pieces. And then, now, this may seem small, but part of what we do, you take that 4 by 7 piece, and instead of using a nice foot shear to get as close to 3 by 5 as possible, you're going to use aviation snips. Does everybody have a set of these in their toolbox? Anybody not have some? Okay, so if you don't, we do have quite a few in the total. So, anyone know what the different colors mean? Excellent. Which one's this one? Whoa. Look at that. Man, so proud of you all. So,
You know that like one handle thing, the touch, is that considered a hand tool?
Beverly, Miss Beverly? No, can't use Beverly. So, use aviation snips to cut it down to a 3x6. And the key thing is the smaller of a slice you make, the better it will be. So if you try to cut too deep and have too much out here, it's going to really distort the metal that you want to save. So do smaller strips will help you not have distorted metal. When you cut it down, I want you to file your edges smooth. Be careful, because if you look down the requirements, each piece must be an exact 3x6. Tolerance is plus or minus 10, 10 thousandths. I'm getting Monday brain. So plus or minus 10 thousandths, and we are going to be measuring these and checking these. All the corners need to have a radius not less than 1/16 and not more than 1/8. So, how do you think would be a nice, easy way to check the corner radius? Exactly. And what do we have around the shop that's a 1/4 inch? Radius. Yes. So, he jumped ahead. So for the 1/8 inch radius, what size of a drill bit would you want to use? Which is 1/4 inch, because that's the diameter of the drill bit. So what you do is you grab your piece and you knock a nice radius onto it with your file, and grab some sandpaper. And this, if you get fairly rough sandpaper, that makes a really nice radius pretty fast. Take fine sandpaper, make it nice and smooth, because I'm going to feel the edges, be like, oh, that's nice, or oh, that's not nice, and get back to you. So then you take the radius and just hold the end of the drill bit up to it and see if the contour is less than a 1/4 inch drill and more than a 1/8 inch drill. So if you have these in your set, you can easily check that. So that's the corner radius. And next thing says shear marks, ragged edges must be filed smooth. So you need to have smooth edges the whole way around. And edge straightness must be plus or minus 10 thousandths. So I'm going to hold it up to something like this and see how straight it is across the bottom and the side. This one's actually kind of decent. And they all must be square within 10 thousandths, which I'll be measuring with this. So all those requirements. Caution on when you're filing. As you file, it's very easy to start light on the edges and go heavy in the middle without even thinking about it. So do think about it and try to have the same pressure the whole way across, and then just check it against the straight edge every so often to make sure you're not dipping down in the middle or overcompensating and going too hard on the side. So straight across is what I'm looking for. So you have the criteria. Once you believe that your 3 practice pieces from scrap metal meet those criteria, then you can bring them as an offering to me or Anna, and we will check that all of those criteria are met. If they are not, all we'll do is, here you go, try again. Or if it's just above and not below the tolerances, you can fix it, bring it back. And then you see there is instructor's initials, so that must get signed off before you move on to anything else. And you should not be moving on to anything else yet. So no riveting yet. Do not be cutting out new aluminum yet, or Anna and I will yell at you. So for today, keep working on deskinning the wing. When you get a couple pieces of scrap metal, you can start cutting out 4 by 7 for everyone, and then each person should have 3 of those pieces to cut down to the exact 3 by 6. Any questions on all of that? Going. Yes.
Got your piece from 4 by 7 to 3 by 6. Would you suggest taping it and marking on the tape? Or would you mark it on aluminum?
I am okay if you mark it on the aluminum as long as it's a Sharpie, because that can be wiped off with alcohol. Thank you for asking that. Any other questions? All right. If you want, you can take a 10-minute break. Other than that, to the lab.